And kites are really a cool thing for me. I really enjoy looking at kites and talking about kites, partially because I'm an avid kite collector as well as just sort of purveyor of kites. I really like to see kites. This is a picture from Longview Community College. You can sort of see this is where like the apartments are at there. This is, I think the CVS is like right over here, kind of in the background. But there are these gigantic kites at the Kite Festival. This one is so big it's actually tethered to the ground as well as tethered to a car that's nearby. This one's huge. They actually are so big that they need to have like guide kites in order to lift them off the ground. This kite would have a hard time fitting inside a classroom, just the wingspan besides the whole tail thing. It is so big. This one over here definitely would not fit. It is so gigantic. I think they had to bring semi trucks just to bring them in. They are so enormous. Some of these that are in sort of the foreground of the picture are a lot smaller. These are about the length of a car or a bus. These ones that are kind of just flying around, these are those giant flags. But this one's in the background. It is enormous. It is probably the size of a bus in itself. I really like kites. I think they're a lot of fun. And geometrically, there's a lot that we can gain just from studying kites. So this is a kite. There's a lot of things that we should know about it to just begin with. For instance, these two opposite sides right here, these two sides are going to be congruent. So if one side is 4, the other side is going to be 4. This side down here, if this is going to be congruent to the side over here. Additionally, one thing that we talk about is if we draw our diagonals in here. This is not drawn very well, but if we draw these diagonals in here, sort of a vertical diagonal, I can think of this diagonal sort of being a line of symmetry. And the idea with this is that anything that's on the left side is going to be symmetrical to anything on the right side. So if I was to talk about this angle, angle A, it's going to be congruent to angle C. So if this is 175 degrees, this will be 175 degrees. If this is 20 degrees, this is 20 degrees. Okay, so that's what we're looking at here. If I draw the other diagonal in, we can gain a lot more insight into what's going on. These diagonals actually are perpendicular bisectors of one another, so it means that they are perpendicular. It means that each one of these 4 angles are going to be 90 degrees. So that's kind of a little bit of symmetry. This angle right here is going to be congruent to this angle right here, again with that symmetry idea. And these angles down here, even though I didn't really draw them very good with this diagonal, those 2 angles will also be congruent. Something else that's congruent is this diagonal. I did say it was a perpendicular bisector. This long diagonal is a perpendicular bisector to this other one, which means that these 2 segments that make up the entire diagonal are also bisected. They're brought apart. We talk about these in a couple of different ways. Some of the angles. This is just called a vertex. Angle, or vertex D down here is also called a vertex. These are called vertex angles then, which makes angles A and C something that's called non-vertex angles. These are kind of weird phrases for them, but they're called non-vertex angles, A and C. From this information, we can kind of glean a lot. In this, on your worksheet here, it's going to talk about how non-vertex angles of a kite are actually congruent. Those are the ones on the right and the left side. The diagonals of a kite, well, they're perpendicular. The diagonal connecting the vertex angles, so from top to bottom, that first diagonal I drew that was up and down of the kite, is the it's the perpendicular bisector. It's the perpendicular bisector of the other diagonal. It means it bisected it, cut in half, as well as made a perpendicular line with it. Finally, the vertex angles of a kite are said to be bisected. Bisected, that means cut in half by a diagonal. So those are some things that we'll look at as we work with this stuff. It says A, B, C, D is a kite, and we want to find the perimeter. Well, if this side right here is 12, that means this side down here is 12. We know these 2 sides are also congruent, so if this side's 20, this other side has to be 20. Perimeter is just adding up to each of the sides, so that'd be 20 plus 20 plus 12 plus 12, and that would give us a perimeter of 64 centimeters. I think it's pretty important to have the units with this as well. If we look up here at number 2, we notice that this is a non-vertex angle. This is also a non-vertex angle, so right away we can come up here and say that y is going to be 146 degrees. Because this is a quadrilateral, we can actually say that the sum of the interior angles is 360 degrees. I mean that we can say 146 plus 146 plus the 47 in the vertex plus x, which is in the other vertex, should equal 360. If I combine like terms, that's 360 is equal to 339 plus x. If I subtract 339 from both sides, I find out that x should equal 21 or 21 degrees. So that gives us an x, that gives us a y here in order for us to figure these out. Number 3 is a little bit more complicated. It takes into account that the amount of symmetry involved. If I look at this bottom triangle here, this bottom left triangle, let's see if I can draw this. If I know this is 29 degrees, I also know this part here is 29 degrees. And I know that this is a right angle. So I can set up an equation that says y plus 29 plus 90 degrees equals 180 degrees. It's just using the triangle sum theorem. In other words, y plus 119 has to equal 180 degrees. Or when I subtract 119 from both sides, y is going to equal 61 degrees. I can do a very similar process up here with the x's. So I'll just concentrate my effort on this triangle up here. This angle will then have to be 18 degrees. And this is a right angle as well. Using the triangle sum theorem, I can say x plus 18 plus 90 degrees has to equal 180. That means that x plus 108 equals 180, and that x equals 72. You'd say 72 degrees, or just that x equals 72. Next, we're given this giant shape here. It says example 4. What we're going to do is we're going to try to label the kite above to reflect all the given information. When I do this, I like to say not only that QT is 4, but also since QT and TS are congruent, I'm also going to label TS as 4. So that takes care of that information. PT is 5. That takes care of that. RS is 12. That's going to be down here. This is 12. Because PR is our line of symmetry, I can also say that this side up here is also 12. So in essence, anything up above is going to be congruent to anything down below. So let's see how that turns out. PQ, it says is 6.4, so this is 6.4. This side right here is going to be congruent to PS, this side down here, so I'll also label it as 6.4. Angle QPT says it's 35 degrees, so I'll put that right here. This is 35 degrees. Just right here. I know it's going to be congruent to this angle here, which is also 35 degrees. Tough to squeeze it in there. This is QRT, so Q to R and then to T, so this angle right here. It says that's going to be 18 degrees, so I'll put an 18 right there. I know it's going to be congruent to this angle right here, so I'll put an 18 degrees right there. And finally, RQP, so R, Q, and P, sort of this big angle right here. The non-vertex angle, let's see if I can get enough arcs in here, that's going to be equal to 78 degrees, which means that this angle down here that spans this entire width here is also going to be 78 degrees. I like to label all that information, kind of crossing it out as I go along, and also kind of showing each piece that's going to be congruent. One thing I don't know is I don't know this length right here. And that kind of worries me that I don't know this length. I figure maybe I need to know that later on. It says find each of the following if there is not enough information, right cannot determine. So I'm looking at QS. Q goes from Q to S. That's going to be 4 plus 4, which is 8. As for TS, that's just going to be this one short segment, so that's just going to be 4. It asks for angle QPS, so Q to P to S, that's going to be 35 plus 35, or just 70 degrees. As for QRS, so Q to R to S, that's going to be both this 18 and this 18, so that's 36 degrees. It asks for PR, P all the way over here to R. Well, that'd be 5 plus whatever this length is. Now, it didn't give me this length, but if I was to use the Pythagorean theorem, I could say something like, if I labeled this as x, I could say 4 squared plus x squared has to equal 12 squared. This is 16 plus x squared is equal to 144. If I subtracted 16 from both sides, I could say x is equal to, let's see, 144 minus 16 should be 128. And then x would be the square root of 128, which is kind of going to be a mess. I don't think it really wants us to do this. It says, well, you don't know this right offhand from the information I gave or any of these properties that I had. So even though I could figure it out and say it's 5 plus whatever this is, I'm going to actually use the directions and say if there's not enough information right, cannot determine. And we'll talk about the Pythagorean theorem another day for us. So cannot determine. I'll write that here for this one. The next asks for angle QTR, so from Q to T to R. This is just going to be one of the perpendicular angles, so this will just be 90 degrees. STP is another angle that is made up by the perpendicular lines, STP, just going out like so. Angle PST, so from P to S and up to T. I could probably figure this one out as well. This is 90 degrees, so if I was to concentrate on, let me switch colors, if I was just going to concentrate on this one triangle right here, if I know that this angle is 35, and this angle is 90, I could probably figure out this angle here. Let me label that as y, so I have another variable. So I have 35 plus 90 plus y has to equal 180 degrees. This would be 125 plus y equals 180. Or in other words, y is going to equal 55 degrees. I think there's enough information for us to figure that one out. I'm not going to write cannot determine, even though it was more of a difficult thing for us to find with just the information given. I think this one would be a lot more complicated. QR is from Q down to R. That's just going to be a length of 12. And PS is going to be from here down to here. That's just going to be 6.4. They don't always put the hard ones at the end or the beginning. They sometimes kind of mix them in between. The next thing it says is what is the length of the perimeter. The perimeter is just going to be sort of the entire kite. Ooh, it's just going to be this sort of outline here. Oh, this is a really bad outline. But basically the outline of the kite. So I'm simply going to take 12 plus 12 plus 6.4 plus 6.4. That should give me 36.8 inches or meters or whatever our units are going to be for this. Okay, so perimeter again is the outside, the lengths outside, and you're just going to add them together. Finally, it says if the perimeter of a kite is 36, somebody just say that, the perimeter equals 136, and one side equals 128, what are the lengths of the other sides? So what I'm looking for is I'm looking for the lengths. We all know that a kite has 4 sides, so if it only gave me one side, I'm going to have 3 answers here to give. So if I just draw a kite really quickly, well, this is not a very good looking kite. I know that one side is 28. I know this other side is also going to be 28. So that's going to be one of my 4 answers, or 3 answers. I know these 2 sides are going to be congruent, so if I label one of them x and the other one x, I can then write an equation where that's going to be x plus 28 plus 28. That has to equal my perimeter. That's sort of adding up all 4 sides. That's going to equal 136. I had a student earlier today asking me, why doesn't that equal 360? It seems that we were constantly adding up 4 things equaling to 360 the last couple days. Well, that's going to be the sum of the interior angles. So if I was concentrating on each of these 4 angles and adding those angles up, I would have 360. Since now I'm concentrating on the outside, the lengths of the side, I'm talking about the perimeter, I'm going to focus on the perimeter being 136. This will give me 2x plus 56 equals 136. When I subtract 56 from both sides, I'd have 2x equals 80, or just x equals 40. In my picture, that means that this side over here is 40, this side over here is equal to 40, and if I want to answer my question, both sides, or all 3 sides, are going to be 28, 40, and 40.